Hello, my dear students. This is P. Venkateshwarlu, PGT Physics, Dinandal Public School. So, next month, 12th onwards, we have midterm exams. So, due to that, we have to revision classes. Okay, my dear children, revision classes going on from today onwards. So, in any gap, I will explain remaining content. Okay, today I will explain uniform and non-uniform motion. Okay, so if any doubts, contact me offline call or online call, my children. To uniform motion in a straight line, uniform and non-uniform motion. Uniform and non-uniform. Uniform and non-uniform motion. Okay, so when a body is said to be uniform motion, coming to uniform motion, when a body is said to be uniform motion, the body covers equal distance or displacement covering equal intervals time. So when a body is said to be uniform motion means that body covers equal distance or displacement covers in equal interval of time, equal intervals of time. Okay, so when a body is said to be uniform motion means the body covers equal distances in equal interval of time. Okay, so coming to non-uniform motion. Non-uniform motion. Non-uniform motion means equal distances covered in unequal interval of time. Okay, coming to non-uniform motion, equal interval, equal distance or displacement in unequal interval of time. Okay, so equal distances covering unequal interval of time. Okay, so this we can say non-uniform motion. This we can say non-uniform motion. So example for uniform and non-uniform motion. Okay, so let us assume a body. So the body name is T. Mohan Reddy, TMR. Okay, starting from rest. The body covers every 200 meters in every 20 seconds. Okay, 200 meters covers in 20 seconds. Again 200 meters covering same time. Okay. So this Mohan Reddy is said to be Mohan Reddy in uniform motion. Okay. So according to the definition, equal distances covering equal interval of time. Okay. So 200 meters covering 20 seconds. 200 meters covering next 20 seconds. This type of motion we can say uniform motion. Coming to example of non-uniform motion. Okay, so consider a car or bus. Consider a car. Okay, consider a car. At t is equal to 0. The car is at rest. Okay, so within the span of time. For 10 seconds, the car covers 500 meters. So next 10 seconds, car covers 1 kilometer. Okay, understand? Here, so unequal distances covering unequal time are unequal distances covering equal interval of time. So any one of distance or time will changes, continuously changes. Okay, understand? Coming to graphs. Okay, so we can represent a graph x y coordinate system. X direction along x axis always you have to take time. It is denoted t, unit is second. Along y axis distance or displacement. Distance or displacement we can measure in meters. So symbol is x. Time is t, symbol is s. Here, according to the definition, equal distances covering equal interval of time. Okay, the graph is passing from the origin. So for uniform motion, this is for uniform motion. Okay, at the same time, when object is at rest condition, time in seconds, displacement or distance in meters, like this. You can get graph like this, x-axis, y-axis. Okay, so graph means it is a pictorial representation of the information of describing of motion of the object. Okay, coming to non-uniform motion means time seconds, distance or displacement in meters. Okay, so already I said unequal distances or unequal interval of time, it covers equal distance like this. So this type of graph represents non-uniform motion. Non-uniform motion. Okay, coming to speed and velocity. So anybody define speed? Speed is defined as distance per unit time. Speed is defined as the rate of change of its position. Or distance divided by time. Speed is equal to distance by time. The ratio of the distance to the time taken is called speed. Okay, so it is a scalar quantity. So scalar quantity means a physical quantity having only magnitude is called scalar quantity. Okay, it's having units, SI units, meter per second. Okay, so other units are multiple units, kilometer per hour. So there is a relation between kilometer per hour and meter per second. 1 kilometer per hour is equal to 5/18 meter per second. Okay, so this is the conversion from multiple unit to SI system. We can use regularly, the speed is kilometer per hour. So if we can change kilometer per hour into meter per second, simply we can multiply with 5/18, we can get a meter per second. Okay, so kilometer per hour is equal to 5/18 meters per second. So we know that speed is defined as the ratio of distance to the time taken or the rate of change of its position. Coming to velocity. So velocity is defined as rate of change of displacement. Rate of change of displacement. rate of change of displacement. Velocity is equal to displacement divided by time. Displacement divided by time. So it is a vector quantity. It is a vector quantity. Okay. So what is vector quantity? A physical quantity having both magnitude and direction is called vector quantity. Coming to SI units. Okay. Both velocity and speed having same SI unit, that is meter per second. So multiple unit is kilometer per hour. We know that conversion. Kilometer hour is equal to 5/18 meter per second. 1 kilometer per hour is equal to 5/18 meter per second. So coming to SI units over, coming to dimension formula. Okay, so dimension formula, you can say DF, dimension formula of speed and velocity is same. So we can discuss about dimension formula in second chapter. It's m power 0, l power 1, t power minus 1.
Coming to uniform and non-uniform speed. Uniform and non-uniform speed. Okay, so in previous we can discuss about uniform and non-uniform motion. Here, uniform, non-uniform speed. We know that speed, the ratio of distance to the time taken by a body. Okay, understand? Speed is equal to distance by time. So coming to this content, uniform and non-uniform speed means uniform speed
is defined as equal distances covering equal interval of time. Okay, so equal distances covering equal intervals of time. Okay, equal distances covering equal interval of time is called uniform speed. Coming to non-uniform speed. Okay, so unequal distances covering equal interval of time. So when a body is said to be uniform speed means the body covers unequal distances in equal intervals of time. Okay, so coming to same uniform and non-uniform velocity. Uniform and non-uniform velocity. You know that the definition of velocity. Velocity is defined as the rate of change of displacement or displacement by time is called velocity. Okay, you know that definition, the rate of change of displacement or velocity is equal to displacement by time taken. Okay, coming to uniform velocity. Uniform velocity is defined as equal displacement. See here, equal displacement in equal intervals of time. Okay, equal distances cover in equal intervals of time. You can say that is uniform velocity. Coming to non-uniform velocity. non-uniform velocity. Okay, so unequal displacement, unequal displacement covers in equal intervals of time. Okay, non-uniform velocity is defined as when a body is said to be non-uniform velocity, that body covers unequal displacement in equal intervals of time. Equal intervals of time. Coming to derivation of average speed. Derivation of average speed. Average speed. Average speed. So average speed is defined as total distance by total time taken. Total distance by total time taken. Here consider a object or consider a car or bus. This is our TNPS van. Okay. So while traveling from TNPS to RGMIS, okay. So the van moves with different distances in different intervals of time. Okay. See here, initially the van is at rest. T is equal to 0. Okay. So the van covers some distance with say it is S1 time T1. Okay, so other distances S2 like T2 and so on, S3, T3, S4, T5, T4. Okay, here, so according to the average speed, the total distance covered by a van to the total interval of time. Average speed is defined as a total distance by total time taken. Average speed, we can say VAVG. Average speed is defined as total distance covered by total time taken. Total time taken. Okay, understand? Average speed is defined as total distance covered in total time taken. Total distance covered in total time taken. So it is also a scalar quantity. So its SI unit is meter per second. Its dimension formula is m power 0, l power 1, t power minus 1. Okay, so coming to derivation. So very important definition. Derivation. Average speed is equal to 2v1 v2 divided by v1 plus very important one for NEET and JEE. The particle covers two places, two equal half of the distance covered into different times is given by V average is equal to v1 v1 v2 divided by v1 plus v2. So this we have to derive. Okay, so for this case, consider a particle and consider 3 points A, B, C. That particle covers half of the distance. The total distance is S. Half of the distance covered with T1 time with V1 velocity. Remaining half of the distance covered in T2 time in V2 time. V2 speed. Okay. So in this case, how we can define average speed. Average speed. Average speed is defined as total distance divided by total time taken. Means total distance means s by 2 plus s by 2 divided by total time means t1 plus t2. Understand? t1 plus t2. Here a particle covers half of the total distance is covered in t1 time with v1 speed. Remaining equal half of the distance covered in t2 time with v2 speed. So average speed is equal to total distance divided by total time taken from the total distance s by 2 plus total time taken t1 plus equal to s divided by 2 divided by v1. Then like t2 is equal to s divided by 2 divided by v2. Okay, understand? Speed is equal to distance by time. Time is equal to speed by distance by speed. So from this we have to write v1 is equal to s by 2 by t1. From this t1 is equal to s by 2 by v1. t2 is equal to s by 2 by v2. So this t1 and t2 can substitute in this equation. S by 2 s by 2 s by 2 s by 2 yes. 2s by 2 can get 2 by 2 gets cancelled yes. Divided by s by 2 divided by v1 plus s by 2 divided by v2. So s by 2 is common. S divided by s by 2 is common. 1 by v1 plus 1 by v2. Okay, here s gets cancelled. This 2 becomes in numerator 2 divided by 1 by v1 plus 1 by v2. 1 by v1 plus 1 by v2. So this 1 by v1 plus 1 by v2 it's become v1 plus v2 divided by v1 into v2. Okay, so this becomes 1 by v plus 1 by v2 it becomes v1 plus v2 divided by v1 into v2. Okay, understand? So rearrange this 2 divided by v1 plus v2 divided by v1 into v2. Okay, rearrange this you can get 2 v1 v2 divided by v1 plus v2. Okay, so this is the important derivation. So based on this formula we can have number of problems already given in previous NEET or JEE. Here given two velocities or two speeds, v1 is equal to v2 is equal to. So first speed is given 40 kilometer per hour. Next one 60 kilometer per hour. Okay. So this we know that average speed of a particle, the particle covers half of the distance with v1 speed or v1 velocity. Remaining half of the distance or displacement is covered in t2 time with v2 speed or v2 velocity. Okay, the formula is same both for speed and velocity. Okay, so half of the distance covered with v1 velocity, remaining half of the distance covered with v2 speed or v2 velocity. How we can find average speed or average velocity? VAVG, which is equal to 2v1 v2 divided by v1 plus v2, that is equal to 2 into v1 40 v2 60 divided by V1 40 plus 60. That is equal to 2 into 40 into 60 divided by 40 plus 60 100. 0 0 0 0 gets cancelled. Okay. 4 6 24 into 2 48. VAVG is equal to 48 kilometer per hour. 48 kilometer per hour.